All right, this is practice 5, number 3. Getting a little more challenging now. Okay, right out of a college physics textbook picture. A block, mass of 5 kilograms, is moving at 2 meters per second when it is at a height of 1.2 meters above the table. The block hits the spring and comes to a stop when it is at the table level. The spring is compressed 0.4 meters. What is the spring constant? Assume 5 joules of energy are dissipated due to friction. Okay? All right, so they kind of give you a little sketch. Okay, and I'll try to draw a little tiny one here in my little tiny place. Okay, after I put on the pencil. Okay, all right, so you have a block that starts up here, okay, and then after it hits against the spring, it's at the table level, okay? So just pick apart each piece, like don't make it hard, right? Don't make it harder than it has to be, right? Just pick apart each piece and try to figure out what's happening, okay? All right, so in position A, which is gonna be up here, B will be down here, okay? When it's at the top of the ramp, is it above the ground? Yes. Okay, is it moving? Okay, so you have to look at the problem. A block is moving at 2 meters per second, so yes. Okay, are there any springs stretched or compressed? No. There is a spring, but it's not yet stretched or compressed, so there's nothing. Okay, and never ED in position A. Never in A. Okay, all right, so we only have 2 energies there, so let's go ahead and see if we can solve for those. Okay, I'm only going to have this one, EK, none of this, and none of this, all right? So the EK is going to be 1/2. The mass of the block is 5 kilograms, okay? And it's moving at 2 meters per second. You have to square that. Okay, so 1/2 times 5 times 4 is going to be, what, 10? Yeah, 10 joules. Okay, and then for the EG, I've got the mass is 5 kilograms. The G is 10 newtons per kilogram always. Okay, and the height is 1.2 meters above the table. All right, so I'm going to have 5 times 10 times 1.2. 5 times 10 times 1.2, 60. Okay, all right, so if I have no ED, no EE, 10 joules of EK, 60 joules of EG, that's going to give me 70 joules of total energy to work with. Okay, so that's going to be 70. All right. Most of it's EG, so I'm going to fill it up almost to the top with EG, and there's just a little bit left over for EK, you know, like, I don't know, 15% or so maybe. EK mostly is EG. Okay, all right, now let's look at the bottom position. All right, I know the total energy is still going to be 70, so that doesn't change. Okay, uh-oh, I'm running out of space here. Can I move that? Well, you just have to just guess. Okay, is it above the ground? Yes. Okay, is it moving? Okay. The block hits the spring and comes to a stop, so no. Is there a spring, stretched, or compressed? Yes. And is there ED? Yes. Let me see if I can move this. I don't know if this is going to work. Okay, I hope that worked. Okay, and is there ED? Yes, it says there's 5 joules dissipated. So I'm going to fill that in down here. 5 joules, okay. I'm going to have EE for sure because the spring is stretched or compressed. It's not moving, okay, and it's not, whoops, it's not above the ground, sorry. That should have been a no. Okay, it's not above the ground, it's not moving, it has ED and it has EE. Okay, sorry about that. All right, so that's nothing, okay. So if there's 5 joules of ED and 70 joules total, that means that this has to be 65 because the total has to add up. All the energies have to add up to the total. Okay, so 65 joules is going to be 1/2 K times 0.4 squared. Okay, so I'm going to take out the units for now. So 65, oops, equals 0.4 squared is 0.16. Okay, times 1/2 is 0.08 K. All right, now divide by 0.08. 65 divided by 0.08, and I get a spring constant of 812.5, and remember spring constants are in newtons per meter. It's telling you the strength of the spring, okay, which that's a pretty strong spring right there. All right, so most of it's EE, Okay, there's only a little tiny 5 joules that's ED, so even less than the last one, right? So even skinnier piece for ED, and then EE is most of the pie. Okay, all right, that's number 3.